Assalamu alaikum. Today is the fourth lecture of software quality assurance. In the last lectures, we have talked about what software quality is and how we can remove and how we can prevent defects from coming into our work products. We also understand the benefits of having both defect prevention as well as defect removal strategies in our processes in our companies, so that we can apply them and get rid of these ugly defects that cause lots of problems in our software products and services. We have also looked at the negative consequences. We have discussed some of them, or the bad impact that these defects have on societies, both in terms of financial loss as well as in terms of loss of human life and catastrophic loss of other things. Economies now heavily depend on automated systems, and therefore a lot of effort needs to be given to eliminate defects from the software products and services. And that was the basis of the first three lectures that we have covered so far. And we now fully understand what the benefits are of having in place a software quality assurance program. What software quality assurance programs enable us to do is to look at holistically how we can improve software quality from different perspectives. First of all, we need to have management commitment. We need to have commitment on part of the technical staff. We need to have commitment from the customer side as well, because all the stakeholders, when working together, will then only be able to produce high quality software. And customers have a very important role in this to play. They must demand high quality software, and they must come up with the resources that are necessary to do so. And obviously, the software development companies must also train their people to develop these high quality softwares. And it does not take, it takes an entire company's effort. You cannot expect that only one part of the company is working to develop high quality software. All of us, all of the IT professionals, all of the software professionals have to work together with the management's help and blessings to develop high quality software. Having said that, our industry is still suffering from products which are not of high quality. As I had said when we were discussing the negative impact of software defects, that almost $59 billion US dollars are wasted every year because of software defects, and that's only in US. Today what we are going to do is we are going to look at some of the companies which produce bad quality software. We're not going to look at them in terms of who they are, but we are going to look at them at some of their practices. We are going to look at the reasons for poor quality software. That's where we are going to begin today, and then we will look at why there are companies which cannot produce high quality software. So we'll look at some of the bad practices. And we'll also look at some good practices that will enable us to produce high quality software. So what are these root causes of poor quality software? Let's look at them. you are looking at three root causes of poor software quality. These are the first three. We have another slide that you will see. The first one, and I'll read, is inadequate training of managers and staff. Then you have inadequate defect and cost measurement. And third one is excessive schedule pressure. Now let's discuss all three of them, and then we will take up the next three. We were talking about education and training in one of the previous lectures, and we discussed the fact that if we provide good enough education and good enough training, then we can eliminate many of the people-based sources for software defects. So if you look at the reasons carefully of poor quality software, the first reason that jumps out is inadequate training of managers and staff. That is, the management is not aware of the necessary practices, procedures, and technologies that are important for developing high quality software. And the staff is only, that is the technical staff, is only trained in the latest technologies. They do not want to practice some time consuming but very effective ways of developing software. And I said time consuming because it appears that they are time consuming, but at the end of the day they save a lot of time as well as money for the developer. So it is the responsibility then of the company management to provide adequate training to middle line management as well as technical staff to make them aware of the importance of software quality, and whenever there is a need for technical training or management training, that should also be provided. The second reason that you have just seen is inadequate defect and cost measurement. Software measurements is a very interesting but still not very popular in our industry. Measurements are the ways by which we know whether we are improving or we are not improving, or we are falling behind. And for us who care about software quality, there has to be a mechanism in which we measure different aspects of defects. And we will talk about what defect measurements are in another lecture. But suffice is to say at this time that the companies which produce poor quality software do not have any sort of defect or cost measurement programs in place in their practices. And as a result, they don't know if their defects are growing or if their defects are in a particular area, or if they are not comfortable, if that is the technical staff is not comfortable with the application domains, or they lack knowledge in their particular technology areas. And so unless we have these measurement programs in place, we will not be able to provide adequate training. And so these 2 points are again related to each other. In order for us to provide accurate and adequate training, we need to know which areas the trainings should be focused on. And unless we have some sort of measurement program in place, we will not know which areas we are lacking in. And so this is a connection which is very obvious and intuitive. The third point that you had just seen on the screen was excessive schedule pressure. Now, when we observe the software industry and we observe information technology companies, the way they do businesses, the way the timelines are reduced very often, we note that there is a schedule pressure on all projects. There's hardly a project where you have unlimited time available to you. Even research projects have restrictions on time. And so there is need for us to realize that schedule pressure is going to be there in IT projects. However, if this schedule pressure becomes uncomfortably difficult or excessive to the point where the productivity of the IT professionals goes down, then it is obvious that the quality of the software that they will produce will be very bad. And so management needs to look at the schedule load and pressure on the IT staff also. And they have to make it to a reasonable time so that employees can have limited pressure on them and they can produce high quality software. Now let's look at the next three root causes of poor quality software. The root causes that you see here are insufficient defect removal, high complexity levels, and ambiguous and creeping requirements in design. This is also known as feature race and gimmicks. Keep these three in mind and we'll discuss them now. Let's take the first one here on the screen. Insufficient defect removal. Remember we talked about the bad impact of having defects in our software products? The results can be catastrophic. And there is another thing, that is the morale of the professionals will also go down if we keep producing bad software, because we have not taken the care to eliminate them. We have not applied inspections and testing enough to ensure that the defect removal efficiency is fairly high. And so whenever you look at these companies which have these problems, you will notice that they do not apply all the defect removal techniques that are available to them from a number of resources. And again, this goes back to the education and training concept, that the companies realize that they can cut corners by not providing enough training, but what they don't realize is that there is financial loss as a result of saving some money. Then there are certain domains which are complex. And one of the things we talked about is cyclomatic and essential complexities go up as the domains become complex and difficult. Let's, for example, take complex aerospace or atmospheric domains which have a large number of parameters and so many unknown aspects that are very difficult to comprehend by humans in holistically. It's very difficult to understand them completely. And so there are unbounded complexities with these domains. And when we try to develop products for unbounded domains, the complexity levels go up naturally. And so wherever you are having such applications, the results are usually unpredictable. And the sixth, and one of the most common root causes of poor quality software, is ambiguous and creeping requirements and designs. Ambiguity is clear, we know that, but creeping requirements are those requirements which are changing all the time. And this happens in our industry more often than we would like to. And this happens when there is competition. Let's say there's a company A which introduced a set of features in their product, and those features are not available in a similar product offered by company B. What the marketing department of company B would like to do is to promise the customers that yes, we will provide those features also, and maybe at a lower cost. And the burden then that gets shifted to the project management and technical staff. And that's why we have those excessive schedule pressures. And so you can see that all these root causes are related to each other in one way or the other. And one would have an impact on the other. And when you have excessive schedule pressure, you have too much functionality to be delivered in a short span of time. Your education and training is not adequate. You're not measuring things like defects and costs and productivity. You have insufficient defect removal, and sometimes on top of it you have high complexity levels. And what else can you expect? You would have poor quality software. Now let's look at the characteristics of the quality laggards, the companies which lag behind in producing high quality software. We had recently just finished discussion on the root causes of poor quality software. But even in this day and age, even with the realization that companies need to produce high quality software, companies realize that they need to eliminate these root causes of software, poor quality software, and develop an environment in the company which promotes the development of high quality software. Even then, we have companies which have not taken this very seriously. So let's have an overview of our industry. If you look at the industry as a whole, you may find that in almost 60% of the companies, there are no quality assurance programs. Okay, now that's very strange. We know we need to have high quality software. Everyone agrees with it. But still 60% of the companies have no quality assurance program. 20% have token quality assurance programs. So that's our 80% of the industry. 60% have no quality assurance programs, 20% have token quality assurance programs, 15% have passive quality assurance programs, 15%, and only 5% have active quality assurance programs. Compare these numbers, these percentages, with the $59 billion losses every year in United States only. We know the reason. The reason is that the companies are not putting their money where the mouth is, and they need to do that, and the mouth is in software quality assurance. There's another point that must also be understood, and that is that the software quality varies from industries to industries, and it must vary from industry to industry. And because software varies from industry to industry. Software is one of those fluid things which takes different shapes and forms depending on the requirements and needs. The focus on software quality naturally is dependent on the industry, as well as the importance of the application in that industry. So every industry, every profession has, every trade has certain areas which are very important. Some are moderately important, some are less important. And so those areas which are very important, the quality of software applications in those areas must be very high. And then you have moderate applications. Naturally, the software quality of applications running in that area would be moderately high. And then we have areas which are less important in the overall scheme of things in that industry, in that business. And naturally, the importance of software quality assurance gets decreased when applications are developed in those areas. I am by no means suggesting that the quality of software in those areas should be poor or bad. What I am saying, however, is that the importance given to those areas is less, and that is natural. However, having said that, I can claim that even in those areas which are not of great importance in a business area or business or domain, there can be ways in which software quality can be kept high. Let's now look at the software quality in 6 sub-industries, and in that way you will have a better understanding of what I'm saying. Let's look at the kinds of software which control physical devices. There are many softwares in medical science, in road transportation, in industries, that is factory floors, in aerospace, in military, and so many others, which control, and in scientific applications, which software is responsible for controlling hardware devices. You need to have high quality software. Then you have information systems that companies build for their own use, accounting softwares, human resource applications, sometimes ERPs, sometimes pensions, payroll sort of softwares. They need to be of high quality. But in your mind, can you compare the two? Can you think of a malfunction in terms of devices having being controlled by software as compared to desktop applications, which even if they crash sometimes are not going to create a catastrophic problem. The third is outsourced or contract software built for clients. This particularly applies for software development companies. They develop software for other companies, and their importance on quality would depend on the contract. Then you have commercial software built by vendors for lease or sale, like any software, like operating system softwares, like word processing softwares that we go and buy. They have another level of software quality. The number of people, a number of users of this type of software is very, very high. Then there is military software. You know that in the modern days, wars are operated on and controlled by computers and computer software. There's a lot of information technology, there's a lot of intercommunication between this unit and that unit, and the latest military hardware is all controlled by software. And so there is a level of importance. The degree of rigor in this sort of software development has to be very, very high. This is obvious. And so the quality of software in such industries has to be extremely high. And then there is personal software, end user software built for private use by vendors or individuals and companies or anybody else. You can say computer games would fall into that, chatting software would fall into that sort of thing. Although we would like to have highest possible quality, but obviously when there is highest possible quality, there has to be a cost attached to it. So even if my game crashes during when I'm playing a session, during a session, it's going to be a bothersome thing, but it's certainly not going to, the roof will not fall on me. But if you have some other kinds of softwares, like the ones we discussed just now, the roof can fall on us. And so we need to pay attention to the application area, to the business that we are, for the business in which we are doing software development, and attach quality standards with respect to that application. And there is also a cost factor associated with quality. So let's now discuss the quality laggards and see what kind of characteristics they have. This was a discussion. Before I want to make one point clear, is that these are general characteristics. Some of them may not be applicable to some companies, to some industries, and to enforce, and if you think that you can enforce all the good characteristics on one company without considering the areas in which software is being developed, it would be not prudent. And so as a professional, you need to know the importance of each practice with respect to that application domain. You cannot blindly apply everything to every company. Now, if you broadly look at companies which perform poorly in software development, they are known as quality laggards. you will notice that these companies have no software quality measurement programs of any kind. This is the first observation. No software quality program of any kind. Secondly, they don't use formal design and code inspections. So if you look at the first point, the first observation is that they don't have any quality measurement programs. This means that they do not know if their quality is improving, it is not improving, it is static, or it is actually falling down. And so these companies don't know if what the current status of software quality is in these companies. Secondly, they don't use formal design and code inspections. And we had seen in our discussion on defect removal that inspections are a very good way of removing design and code defects. Very effective. And so if you want to improve, a company wants to improve the quality of software products, they must incorporate this. Thirdly, that is, the companies have no knowledge of or concept of defect potentials and defect removal efficiencies. Defect potential is estimating how many defects this product will have and how efficiently we can remove defects from the product before the product is given to the customer. And so another important thing that companies need to realize is that they have to be serious about not only estimating the possibilities of finding defects, but also trying to eliminate them from software products. Another very important and very obvious observation is that quality laggards either have no quality assurance programs or there is an SQA group, but it is understaffed and it's not performing well. Maybe the management has just put an SQA head without authority, and he's been asked to just fulfill a post and fulfill some forms, and he has no say in the management. Similarly, quality laggards do not have trained testing specialists. Remember, we talked about the efficiency of maintenance specialist in defect removal and improving defect repair rates. And so for complex and large projects, there is need for specifically trained testing specialists whose job is basically to write tests and conduct tests on software that's being developed. Quality laggards also do not use quality assurance tools. There are a number of different tools that are available in the market which cover different aspects of software quality. And even if they have those tools, they don't use them properly or not as efficiently as they can be used. Or sometimes professionals are not trained to use those tools, or they may not be collecting the metrics that are necessary to use those tools, And there's a possibility, a number of possible things can come out as a result of not using these tools. But one thing is clear, that if you're not using these tools, then the importance, then you do not understand and appreciate the importance of these quality assurance tools. These tools can help you improve the software quality of the product. And you do not have, that is, these companies do not have estimation on quality of software and reliability of software. See, whenever you are going to have an active SQA program, you need to have measurements, you need to have estimations, you need to have tools which help you in estimation based on previous data. And so if you are not serious about quality assurance, you're naturally not going to spend time and or spend money on these very useful techniques. If you carefully analyze these companies, you find that these companies do not have or are not using project management tools. There are a number of tools for planning and for oversight and tracking and for budgeting and to monitor schedule. There are a number of tools available that are fairly easily available in the market. Similarly, these quality laggards do not consider risk assessments as a necessary part of project management, and how risks can be avoided, and this needs to be done very early in the project lifecycle, and to continuously monitor it. And they do not have planned testing activities. The testing phases may run a number of times. The testing activity may not be using automated test suites. The testing may not be properly documented. And so there are a number of problems with software testing. Remember that testing is a very important part of defect removal strategy. It would come under defect removal instead of defect prevention. We have talked about the importance of managing complexity. We find that complexity is one source of poor software quality, complexity in domain and as well as complexity in the design and code. And so there are a number of tools available to measure the complexity, cyclomatic complexity for example, and to analyze the complexity of software. And companies which are performing poorly in software products and they are working on large projects need to use those tools, and we find that they are not using them. And their defect repair rates are very high. I mean, the defect repair rates are very low, and they're not paying full attention to managing or lowering defect potentials in their software code. The defect removal efficiency of such companies is less than 80%, which would mean that they are passing 20% or more defects to their customers when they hand over the products to them. And that's really bad, because if the customers and users are smart, they'll detect 20% of the defects in the product. And lastly, there is executive and managerial indifference on quality matters and ignorance along with it. The management and executive officers are not interested in improving, or are not educated about improving the quality of software products. And that is the problem of these companies. If the top management agrees to change and commits resources and funding and provides a commitment to improve the software quality, then everything else can be made part of the SQA program, and everything else can be changed. But if the executive and managerial indifference continues on quality matters, then all efforts will really fail. There are a couple of more related issues with quality laggards that I want to talk about. If you look at the staff morale and voluntary attrition rate of employees in quality laggard companies, that will tell you that the people are not happy and are willing to leave at the first possible opportunity. Similarly, the market share and competitive positioning of the company's products will be shrinking. And that ought to send a signal to the executive and managerial position holders to improve or change the way they produce software products. And in some cases there may be litigation, and in some cases such companies may have to recall their products, and that's very bad in terms of the name of the company, and the market share will definitely go down. You would also notice that quality laggards are those companies with highest probabilities of cancelled projects, because they are late, because they have run over their budgets, because they have not provided the necessary functionality in required iterative fashion, and the customer is unhappy. And it is no coincidence that software groups among the quality laggards also tend to be the candidates for immediate replacement by outsourced organizations. That is, that software groups within quality laggards will lose their jobs, will lose their software projects, and those projects will be given to companies outside, and they will be outsourced to companies which produce high quality software. Now, the discussion that we have had is really a doomsday type scenario for software industry. And the fact of the matter is that these are not cooked up reasons. These are not cooked up practices. The industry has been involved in these practices and has not been paying enough attention to issues related to software qualities. Practice and adopting practices, but the good thing is that there are companies which are doing this, which are following processes that end up in producing high quality software. So let's look at some of the practices for producing high quality software. Let's first introduce the concept of quality attributes. Quality attributes set is a way to represent customer quality requirements. So whenever the customer wants quality, they provide you certain non-functional requirements in which they describe their desire for software quality. You have to develop that quality attribute set, and you have to develop your quality assurance program based on that quality attribute set. And for that you have to go and talk to your prospective and current customers. There are basically two categories of quality attributes. Number one is the product specific quality attributes, and number two are organization specific quality attributes. Product specific quality attributes include ease of use of software. It's very simple. You want to be comfortable in using your software. It should be easily and intuitively usable. The documentation should be clear, unambiguous, and available, preferably online, within the software product. Third is defect tolerance. Some sorts of defects can be tolerated, like cosmetic defects. Some sort of defects cannot be tolerated, and you need to have a defect removal program based on the tolerance level of defects. And there's another thing that is known as defect frequency, that certain types of defects can be tolerated, but only if they appear sparingly. But if they appear on every hour or every half hour, then that becomes intolerable. And so you need to look at the frequency of the kinds of defects, and for that you have to talk to the customers. You also need to look at the impact of defects. We have talked about impact in a previous lecture. You also need to provide good packaging for the software product. Ugly packaging is going to result in dislike by the customer. Then you have price versus reliability concept, something I had alluded to earlier in this lecture about the impact of cost on quality. Then there is a very important product-specific attribute, which is performance. In many cases, you cannot compromise on performance. In some cases, you can. Depending on the application domain, depending on the real application, the time of the day, and so forth, performance is a very important attribute. And we will talk about quality attributes and how we measure them in another lecture. Now let's look at organization-specific attributes. There are two major organization-specific attributes. First is service and support, and second is internal processes. Service and support attributes deal with the concept, service and support attributes apply when the product is given to the customer. How quickly we can provide them with upgrades, how quickly we can repair defects, how quickly we can give them information on using the software, and how nice a relationship we have with the customer. And secondly, we have internal processes. Internal processes deal with how we develop software. What are the processes? What are the controls? What are the procedures? Are we certified? Are we using a specific process like CMM, CMMI, ISO, Sigma, 6? So depending on the preferences of the customers, we need to improve our processes. We need to adapt new processes if we have to. And this is a very interesting and wide area, and we will talk about different software development processes later in the course. These were the product attributes. Now let's look at very quickly what are some of the practices we can do to achieve high quality, achieve the goal of producing high quality software. We need to have enterprise-wide quality programs. We need to have quality awareness and training methods. We need to have quality standards and guidelines. We need to have quality analysis method. We need to have quality measurement methods. We need to have defect prevention methods. We need to have non-test defect removal methods like inspections or design reviews. We need to have testing defect removal methods. We need to measure the user satisfaction, which is the ultimate definer of quality. And we need to have post-release quality controls. All the best in the class companies, all the companies which produce high quality software have these practices in place. Very important thing, just one thing before the lecture ends today, is that reductions in total defect potentials using reductions in total defect potentials using methods of defect prevention has to be in place. We also need to have improvements in cumulative removal efficiency levels, that is, defect removal efficiency levels. First thing is we have to reduce defect potentials in our products, and secondly we have to have high defect removal efficiencies. If we do not want to be a quality laggard and we want to be a high or best in class software producer, we need to have these two things in place. I'll see you next lecture.